in this video, I'm going to do the simplifying trig expression part of the review sheet that you guys asked me to do. So I have each one of these expressions that's given to me. I want to try to write it as one term that's not a fraction, or as little terms as possible, because sometimes I won't be able to get just one term by itself. But I want to try to get one term by itself that is not a fraction. So for number 1, I have cosine of negative x times sine of pi over 2 minus x. I know cosine of negative x, I can rewrite that more simply as I can get rid of the negative since this is an even function, and I can just write it as cosine of positive x. For the second part here, I have sine of pi over 2 minus x. That's one of the cofunction identities, and I'm going to be able to replace that also with cosine of x. And when I multiply these together, I'm going to get cosine squared of x, and that's one term by itself, so I'm finished, and that's my simplified trig expression. For number 2, I have cotangent squared of theta over cosecant of theta plus 1. And I want this not to be a fraction, so I want to be able to get rid of the fraction. And I also want to be able to rewrite these two terms as one term. I know that if I see cosecant of theta and 1 paired together, there isn't a trig identity that I can think of that I can use, but if I had cosecant squared of theta and 1 together, then there is a trig identity that I can use, and I'm going to write it off to the side. Oh my god, that's messy. Identities. There is that one that we talked about, the Pythagorean identity, that says if I have cotangent squared of theta plus 1, that gives me cosecant squared of theta. So if I had cosecant squared and 1 together, then I could use this Pythagorean identity in order to change that base to be from 2 terms to 1 term. And the way that I can just have these 2 terms but them squared is I could multiply the base by its conjugate, so that I would get the difference of 2 squares. So I'd have cosecant squared of theta minus 1 squared, which is 1. So I'm going to do that. I'm going to multiply the conjugate of the base, so cosecant of theta minus 1, and I'm going to do that in the top and the bottom because I want to multiply by a giant 1 so I don't change the value of that fraction. I'm going to leave the top unfoiled, so I'm going to have cotangent squared of theta, just in case something will cancel. Cotangent squared of theta times cosecant of theta minus 1. Also, if I distributed, it would look really messy and it wouldn't be something that I could change using any identities, so I want to leave it factored, and then hopefully something is going to cancel once I change things with identities that I know. In the denominator, I'll have the difference of 2 squares, so I'll have cosecant squared of theta minus 1. And then from there, I'm going to use this trig identity that I wrote here. I want it to look like this on one side so that I can replace those 2 terms with 1 term. So I'm going to edit this identity a little bit by subtracting 1 on both sides. And I'm going to get cotangent squared of theta is equal to cosecant squared of theta minus 1. That way I know that I can replace now cosecant squared of theta minus 1 with just cotangent squared of theta minus 1. I'm trying to get down terms, so I'm going from the 2 terms to the 1 term. And so I'm going to rewrite this whole fraction as cotangent squared of theta times cosecant of theta minus 1 all over, this is going to be cotangent squared of theta. So I just replaced the denominator from this to this. Now I can see that in the top and the bottom, the cotangent squared of thetas are going to cancel out, and I'm going to be left with just cosecant of theta minus 1. There is no trig identity that I can use to rewrite this. I'm not going to be able to get that to be 1 term. So I'm just going to leave it as the 2 terms. That's as simple as I can write it. There's no simpler way to write that trig expression, so I leave it like that. For number 3, I have cosine of theta times 1 over sine of theta plus cosecant of theta. I'm going to rewrite cosecant of theta to be a fraction that I know it also is. So I have cosine of theta times 1 over sine of theta plus 1 over sine of theta. And the reason I did that was because I knew that cosecant of theta was 1 over sine of theta, and now I have 2 fractions that I could combine into 1 term. So I'll have cosine of theta times 2 over sine of theta if I add those 2 fractions together. And then now if I multiply through, so I have cosine of theta over 1 times 2 over sine of theta. I'll have 2 cosine of theta over sine of theta. And I know cosine of theta over sine of theta is going to be cotangent of theta. And then I have that times 2. So I have one term now by itself. That is my simplified trig expression. For number 4, I have cosine squared of x times sine of x plus sine cubed of x. For this one, what I want to do is I have 2 terms here. I want to see if I can maybe factor something out. That might be a strategy that I can use to change this, because right now I can't use a trig identity to change anything to help me get this to be less terms. So maybe if I factor, then I'll see something different. I see these 2 terms have sine in common, so I can take sine of x out, and I can write this as sine of x times cosine squared of x plus sine squared of x. And now I see conveniently that this inside part here, this is a trig identity that I know. That's one of the Pythagorean identities, and I can replace cosine squared of x plus sine squared of x to be just 1. That times sine of x is what I have here, and so my answer is just sine of x, and that's it. For number 5, I have sine of theta minus cosecant of theta all over cotangent of theta. I was thinking about using the, separating this, because I have 2 terms in the top and 1 in the bottom. So separating it into 2 fractions, but that didn't help me when I tried to do that. In my head, I was like, where would I go from there? I mean, that just adds more steps, I think, so I'm not going to do that. Maybe I'll try to write everything in terms of sine and cosine. So I'll write sine of theta minus, this is 1 over sine of theta in the numerator. All over in the denominator, I have cotangent is going to be cosine of theta over sine of theta. It looks like everything has sine of theta in the denominator except for this. So I can make it have sine of theta in the denominator by multiplying the top and bottom by sine of theta. So then I'd have sine squared of theta over sine of theta minus 1 over sine of theta in the numerator divided by cosine of theta over sine of theta in the denominator, which would give me sine squared of theta minus 1 over sine of theta in the numerator all over cosine of theta over sine of theta in the denominator. The sine of theta in the denominator, I can just cancel out. So I'll end up with a fraction sine squared of theta minus 1 all over cosine of theta. I see sine squared of theta and 1 together, which means I can use the trig identity. So off to the side, I'm going to write this because I need to edit it a little bit. So I can use the trig identity. Cosine squared of theta plus sine squared of theta is equal to 1. And then I can subtract 1 on both sides and get sine squared of theta minus 1 plus cosine squared of theta is equal to 0. And then I could subtract cosine squared of theta on both sides, so I'd get sine squared of theta minus 1 is equal to negative cosine squared of theta. And so I can replace this numerator here with negative cosine squared of theta. So this is going to be negative cosine squared of theta all over cosine of theta. And then I can see that something's going to cancel, so I have a cosine in the top and the bottom that cancels, and I'll be left with just negative cosine of theta. And that'll be my final answer. For number 6, For number 6, I have secant of x minus cosine of x over sine squared of x times secant squared of x. And I think what will help me in this case as well is to rewrite this in terms of sine and cosine. So I'll have 1 over cosine of x minus, I just changed secant of x to be that, minus cosine of x over 1 all over, I'll have sine squared of x times 1 over cosecant squared of x. And so this would be, if I wanted to combine my numerator, I would have cosine squared of x over cosine of x to have the same denominator, so then my numerator would become 1 minus cosine squared of x all over cosine of x in the numerator. And then in the denominator, I would have sine squared of x all over cosine squared of x. I know that if I rewrote this so that it looked like this, divided by sine squared of x all over cosine squared of x, I could flip the division to multiplication and flip my second fraction to its reciprocal, and then I would have 1 minus cosine squared of x all over cosine of x times that, and then I could see that a cosine canceled, and I'd be left with this, and then this I know that I can, because cosine squared and 1 are together, I can use that trig identity, cosine squared of x plus sine squared of x equals 1, and edit it to, I'm going to subtract cosine squared of x on both sides, and I'll get sine squared of x is equal to 1 minus cosine squared of x. So I'll replace this with this, and then I'll have sine squared of x all over 1 times cosine of x over sine squared of x. And then, again, it simplifies down to, when you cancel, just cosine of x. I feel like that was so many answers already.